Hello. Redis Enterprise provides a sub-millisecond local latency access to data. We sometimes need to have the same data available across the world for such a small latency and immediate user experience everywhere, or for disaster recovery, for active-active scenario, for read replication. Redis Enterprise provides two kinds of asynchronous replication: a single direction many-to-one replication, and a bidirectional mesh synchronization with automatic conflict resolution at the operation level without data loss and potentially with causality resolution. Let's see it in action. For this demonstration, we have two standalone Redis Enterprise clusters in the cloud. I will open each of them in a dedicated window and authenticate with my credentials.
Okay, so we have our demo environment with I am connected with the first cluster, so I can use my credential to connect to the first cluster, and then I open a second window on the second cluster here with some credentials in this case. Okay, so I am connected to both clusters. Each cluster has 3 nodes. It's fine, so I'm connected here, and the second one has 3 nodes also.
We have Redis Insight Advanced Client instance to connect to the databases. Let's open the interface and accept the welcome pop-up.
We also have Redis Insight instance. Here it is, so I can open a new window and I can accept the pop-up. So now I have my Redis Insight instance ready.
We also have Prometheus scraping the monitoring metrics from both Redis Enterprise clusters and our standard Grafana dashboards. I will open the Grafana interface and authenticate with my credentials.
Then I also have a Prometheus and Grafana, so I will open a Grafana instance and connect with my credentials. Okay, so it seems that I am ready.
And we finally have a client application instance with our matières benchmark tool installed. I will open a terminal window on a Bastion server to connect to the application instance.
So now I can open the SSH terminal. And connect from the Bastion server to the application, to the benchmark server. So here this terminal is on a different instance which hosts the benchmark tool.
First, we need to create an active-active database. It can be created from any cluster. I will use the first cluster. Ask to create a new active-active database, provide the details of all the participating Redis Enterprise clusters. We only have one in this demo, but we could have many more. Set the maximum size of the database to 1 gig and wait for it to be automatically created on both sides with synchronization up and running.
Let's create a database. So here currently I don't have any database on any side, so I can create an active-active database. Then from that point I am currently on the first cluster. Okay. Then I will have to add a new cluster, the second one, with the same credentials in my case, and the second cluster name is this one, so I can add it. Here it is. join the cluster. Then I can create a database. I can give it a name. I could specify the port, but I will not. Then I can specify the size. I will just increase the size. No specific module, and now I can create it. It is being created on this first cluster, but it also will be created on the second one. Just give it some time for that. So it is created here, and without refreshing on the right side, in the second cluster, the database will appear. Okay, it appeared. You can see that it is replicated, so I can see here the database, and here it is also available here. And we can see that currently this database is synchronized.
Now I will demonstrate the data synchronization in both directions using Redis Insight. I first need to define both databases, then I can create a simple key with 60-second TTL in the first database, read the key and its TTL in the second database, change the value in the second database, read the new value in the first database, let the TTL expire and check the key deletion on both sides.
Now I can use Redis Insight, so let's do it. I can add a database. The first one is in the first cluster, so I can have the endpoint here. I will use, well, let's say the IP, yes or no, I will use the endpoint. So here is the endpoint. And I can add a database. This one is created, I can connect to it. And then I can go here, open the database, choose the endpoint, and I will also add this one. Here we have both databases, one on cluster 1, another one on cluster 2. So I can start on cluster 1, I can add a key manually. I will create a very simple key for this test with a 60-second TTL, so it will automatically expire in 60 seconds. I will call it A, and with a value which will be 1. Okay, so I add the key. The key is added in my database here in the first cluster, and now, so I am on the first cluster, I can connect to the second cluster, here cluster number 2. I can find my key. I can see that my TTL is slowly decreasing. I can edit my key on the second cluster. I can change the value. I update it on the second cluster, and now I can go back to the first cluster, this one. Here I can see that A, the key A with the updated value, with a TTL which is still decreasing. So we can wait for this TTL to expire. We will refresh, activate the auto refresh, so you can follow the TTL value without refreshing manually. So 6 seconds before expiration. Next refresh, it should be expired. It is expired. Here on the first cluster, we can connect to the second cluster. Here it is, and we don't have the key anymore, so it also expired on the second cluster. It expired on both sides, so we had the synchronization for the create, for the update, for the read, and for the deletion.
Finally, I will run our matières benchmark tool to read and write as much as it can without limitation. It is only limited by the benchmark instance processing, the network bandwidth, and the database sizing. In the meantime, I will see our Grafana monitoring dashboard and check for the operation replication lag, the number of operations pending for replication. keeping in mind that the heavy benchmark load is not limited and that the database is single-sharded database with active-active replication and with local high availability on both sides.
Now to start a benchmark, we can go to the application benchmark terminal. We can use the command line to connect to the database. We will use the first database. So here I will remove this and replace it with the database endpoint, and I will use the right port number, so 16202. Can start it. So the benchmark is started. I can see that here on this database I have the metrics about this benchmark. I can move to have the latency on the right. Here I have. You have to keep in mind that this benchmark tool is doing to try to read and write as much as it can, whatever the sizing of the database is. And on the second side, we have the passive, in some case the disaster recovery, the standby cluster, which is receiving all the updates from the first cluster. Okay, we have it's currently heavy loaded. We can zoom on the Grafana dashboard. So we have the Grafana dashboard here, and we can open this one, which is relative to replicated database, and I can just increase the size of this window to have better view. And not 1 hour, but maybe 15 minutes, it will be enough. I have my first cluster here defined, and I will use a second cluster here. So I have a lot of metrics available, and I will just fold all these panels, and here I have the synchronization status with the operations which are pending for replication. So here I can see that I have few operations which are waiting to be replicated, and here I have the rate of the removal of operations in this queue, and I have some latency here. So we can see that if we stop the benchmark, the queue will automatically drain. I can manually refresh this graph, or maybe auto refresh every 5 seconds, and these graphs will go down. It's not, the reporting is not immediate, so just have to wait a few seconds. And in the meantime, I can remind you that everything was made in an undersized database with only one shard, and with a benchmark tool which tries very hard to overload this database. So everything is drained. Keep in mind also that the metrics and the monitoring tool is not real time, so it has to scrap the metrics from Redis on both sides, and then to display it.
We have seen how easy it is to create a cross-region active-active synchronized database that all the operations are synchronized, the replication performances under an heavy load, and the provided metrics in a Grafana monitoring dashboard. I hope that you enjoyed this demonstration. Thank you.
With Redis Cloud managed instances, it is quite easy. You have to create a new database, choose the subscription that you want, and then choose the cloud provider and active. And then you can choose your own regions if you want. So let's take, for example, I will take Sydney here, and Melbourne, for example. And then multi-AZ is checked on by default. You cannot change it. You have to define your own CIDR. So first one, for example, they have to be non-conflicting with your own VPC, because later when you want to do a VPC peering, you need to avoid any conflict. Well, if you want auto-tiering, you can, but it's another topic. Then continue. You have to name your database, so I will give it a name. And choose a version, choose the module that you want in the database, size, save the configuration. That's fine. I will have one database, so I can create this only one database. And then I have some kind of summary. I can confirm and pay, and then the database will be created in few minutes. The database is being created while the subscription with the clusters, so one cluster in Sydney, one cluster in Melbourne, and then in each cluster a database will be created. This database will be configured, so we can check here the configuration if we want. Currently the slow log and metrics are not populated because the database is still under creation. And then we can also have another view of the subscription, meaning the two clusters. Later, when it will be created, we can define VPC peerings if we need. And well, we also have information about the regions. So now we have to wait for the database to be created. The database is still being created, so it can take a few minutes. So we have to wait for the database to be created. So database creation is finishing. The database is active. So if I go to the tab, I can see the information, but it's not already fully available. Now it should be. Yes, it is now. I can connect if I want using either a command line client or Redis integration with a client library, or potentially also Redis Insight. So that's all for this database creation. It has two databases with active replication between them, between two regions in the world, and everything is fully managed.